Good afternoon, everyone. I'm glad to be the first one to talk about the Campanian Ignimbrite, and we're going to be showing to you the results that we have from the Lago Grande di Monticchio, which is a high-resolution distal tephra record in Italy, and how we can use the tephra not just to study the tephra chronology, but to understand the life cycle of the Neapolitan volcanoes. So here is the location of Monticchio, which is east 150 kilometers, more or less, from east of Naples region. So it's located really downstream of most of the volcanic regions in southern Italy, and especially the most active ones that we have record in Monticchio. And Monticchio, the good thing about the Monticchio is that most of this lake actually records the VARV record. A VARV record is a lake that has this biogeochemical capacity of recording 1 year cycle of deposition. So for instance, here we have the winter layer, where you have the organic classic, followed by the summer layer, and then you have that for over more than 100,000 years. Most of the records have this property. So you have like an independent chronology, and over time you have the deposition of the tephra in this record. So you can use actually independent geochronology record based on the VARV to tell how old is that tephra and relative to the other tephras that you have on this record. So in this study, Monticchio, it's been working for several years back and goes down, especially in some of the MO core, which goes up to the beginning of the light cycle. So you can have the whole period of the beginning of the lacustrine phase, where it's beginning to form, until the recent times. So you have this nomenclature where we have all the tephra layers that being visible tephra layers that being given a name, and then you see the thickness of each of these layers compared to the other ones that were found throughout the years. The importance of the Monticchio in terms of tephra chronology is actually to have this huge record where you can have the tephra that's also found in other lacustrine records and continental records. So it's actually this capacity of the tephra chronology that begin to work with the Lago Grande di Monticchio. But in this case, I'm going to present in a different perspective, which is to show the whole record, or everything that we analyzed throughout the years, and my part of my PhD, which is to analyze all the other tephra, visible tephra that was not published so far. So in total, we have like I analyzed about 700 tephra shards from 73 visible tephra layers from the 40 and 106,000 years. So that's the layers that were not published yet in terms of major elements. And accompanying that, we have 110 visible tephra layers that we're analyzing to the bottom of the record. So you have like a huge amount of data. And then here I'm separating the data which is characteristic of the Camplifigrade, and following up in the end of the presentation, I'm going to show compared to the Ischia, which are the two volcanoes that have most of the tephra in this record. So in essence, the Monticchio record in terms of the major elements, they don't change very much in some elements. For instance, the silica, it's very small compared to the more like recent ones. So this graph is a biplot that you have the oldest ones are the purple and blue until the more recent one, which is really prior to the Campanian Ignimbrite. So you see the whole record until the major explosion of the Campanian Ignimbrite. So you can see that, for instance, the general idea is that the older layers are very like, for instance, poor in sodium and then become rich in sodium, and then potassium the other way around. And you see that the element that most like varies through the record is actually the calcium. That's why it's here on the bottom. And you can see that when you plot against one each other, Campofagre and Ischia, and you see that over time there's these injections of more primitive calcium-rich magmas, and compared to the, for instance, the proposed or also no caldera formations like Campanian Ignimbrite, the white tree and the Neapolitan yellow tuff, and the green tuff from Ischia. You see that there's huge gap in where there's a lot of injection of this calcium, but it didn't produce much, at least for Campofagre, that you know these caldera forming events over time. But you see there's a recurrence of the calcium over time in Campofagre. In terms of the trace elements, we have like a more show clear tendency to higher high field strength elements. So you see that the elements, the layers that are closer to the Campanian Ignimbrite are much richer in the high field strength, while in the case of the older layers are more like large ion lithophile elements. So you see that this baryon and also more strontium, showing that there's a shift right before this build-up phase of where the nodes, like for instance, before the Campanian Ignimbrite, we have, for instance, this shift in the sea. It's going. So you see that there is a shift around 40,000 where you have the Ischia and the Campofagre systems, they are separate in terms of elements. So they, when you have like, for instance, the green tuff of the period, they kind of couple together, around this time. And then you have like back again, more in recent layers, you have a decouple. So these shifts between the Campanian, the Campofagre and the Ischia seems to converge around the caldera forming events, while during the periods of more like steroid explosive eruptions, like the more primitive ones, the systems are separated and they have different compositions in terms of measure and trace elements. So my key conclusion from these projects, like this part, that you can actually use, for instance, these high resolution records to understand the evolution of the magmatic system of these volcanoes, while you couldn't be doing that near the volcanic regions because of the lack of the near deposits. And the Campofagre and Ischia, when you compare this over time, you see these magmatic systems, maybe they are linked for a period of time, and they are decoupled and back and forth, depending on how like there is the possible the connections of these magmatic systems. Thank you.